Chapter 3, problem number 12. On a spacecraft, two engines are turned on for 684 seconds at a moment when the velocity of the craft has x and y components of 4,370 meters per second and 6,280 meters per second. While the engines are firing, the craft undergoes a displacement that has components of x equals 4.11 times 10 to the 6 meters and y equals 6.07 times 10 to the 6 meters. Find the x and y components of the craft's acceleration. So we have two velocities. Okay, we have a velocity to the right, and that's our VOX. That's equal to 4,370. And we have another velocity in the y, which is 6,280. The engines are firing, and the object undergoes a displacement in the x of 4.11 times 10 to the 6. And in the y of 6.07 times 10 to the 6. And this occurs over a time interval that's given as 684 seconds. And they want to know the x and y components of the craft's acceleration. So ax and ay. So we know time, we know displacement, and we know original velocities. So it looks like the equation for finding acceleration in the x would be delta x is equal to VOX delta t plus 1/2 the acceleration in the x times the time squared. And in the y, acceleration in the y could be found by using delta y, displacement in the y, is equal to VOY, the original velocity in the y, times the time interval plus 1/2 the acceleration in the y times the time squared. So we'll solve this equation for AX. So we get and the other equation for AY now we can substitute in the given information. So this is 2 times 4.11 times the 6 meters per second. No, just meters, excuse me. Minus VOX is 4,370 meters per second. Multiplied by the time, 684 seconds. All divided by 684 seconds squared. Okay, down here, take 2 multiplied by delta y 6.07 times 10 to the 6 meters minus VO y is 6,280 meters per second, multiplied by the time, 684 seconds, all divided by 684 seconds squared. Okay, so let's figure out AX and AY. So AX, acceleration in the X. 684 times 4,370. I'm going to put that into memory. 4.11 times 10 to the 6. Add that to what I have in memory. Multiply that by 2 and divide that by 684 twice. And I'm getting 4.8 meters per second squared. Okay, is the acceleration in the X. In the Y, oh, there's my calculator. Okay, we take 684, multiply it by 6,280, put that into memory, and 6.07 10 to the 6 minus what's in memory. I'm going to do that again. 6280 times 684, and then 6.07 10 to the 6, and I'm going to add what's in memory. Okay, now I multiply that by 2 and divide it by 684 squared, and I get 7.6 meters per second squared. Now, what we could do is use the Pythagorean theorem and determine the magnitude of the acceleration, and then use a trig function to figure out the angle of the acceleration. And then that would be the direction of the net thrust on the spaceship.